Hi everyone. So for today's session, we are practicing statistics. So let's start with, like all the basic questions and, we'll go from basic to advanced. And I'll just try to ask all these questions. If you know the answers, just let me know whatever you think. And let's say if someone has a better answer, let's say Harshit told some answer and let's say Yogesh has a better answer. So Yogesh, like you can raise your hand and you can say, okay, I just want to add my answer to this question. So we can go like that. Does that sound good to everyone?
Yeah.
Okay, perfect, guys. So let's start with we'll go from very basic till we'll go till advanced. Okay, so just let me open my questionnaire. Okay, so what is the difference between population and a sample? Yeah, go Satyaj. Yeah.
Yeah, so population is basically all the data that's available for a specific test or maybe and sample data is a part of the population that might represent the characteristics of the population. So for performing specific test, sample using sample data is better because using the entire population data might be complex and also the computational cost might increase for the for using the entire population, so sample data is used.
Okay, so the question was what is population versus sample, right, Siddharth? So what you elaborated was okay, population is this, and why do we use sample? But coming back to question, what is sample? Let's say if I ask you what is a sample, Harshit, if you want to go about that, if you want to answer that question.
So I would say sample is a subset of the population,
Yeah,
and
perfect.
which can be used for modeling purposes representing the same characteristics of the population, but at a lesser feature level to
Right.
reduce computational costs.
Perfect. So this is the simple answer, right? Population includes everything. Let's take an example. If I'm seeing students in a university, if I count all the students, that is my population. And what is sample? It is a subset of population. Let's say if I'm focusing on computer science students, so that is my sample from the whole population. Okay, so very simple. In simple term, population includes everything. Sample is just a subset of population. So that is in simple words. Okay, so what is the difference? Okay, first, what is descriptive statistics? Yeah, Siddharaj.
Yes, so descriptive statistics basically tells us about the characteristics of the distribution of the sample. So there are measures for the central tendency, there are measures for variability, and also there are measures for the shape. So the central tendency is measured by mean, median, and mode, and variability is measured by range or standard deviation or variance or interquartile range. And the shape can be measured in terms of kurtosis or skewness of the distribution of the sample.
Okay, so yeah, this was like a perfect answer. Nothing more needed, nothing less needed. Perfect answer. Yeah. So what is inferential statistics?
I would say, like, I might be wrong, but uh, concluding some results based on the numbers derived from the statistical analysis.
Yeah, that's right. I mean, yeah, that is one of the definition that inferential statistics is nothing but you're trying to infer from the data. And then once you do the inference, what is the next step is basically building out a relationship between your dependent variable and your independent variable. So Harshit, you are correct on that. Inferential statistics is nothing but it is used to infer our sample data or infer our population, and then we use the inference to build a relationship between our dependent variable and our independent variable. So, okay, perfect. Sounds good. So, can you give some example of inferential statistics?
I would say, uh, based on the statistical analysis, if we are accepting or rejecting a null hypothesis,
Yeah.
can be considered as an example of inferential statistics.
Right. So hypothesis testing is a measure of inferential statistics. Any other measure you can think of?
We can also consider a confidence interval
Right.
also,
Right.
and
This one thing which you all have studied is regression analysis, right?
regression.
Which is
Uh,
used to develop or model the relationship between your dependent and independent variable, right? So as you said, hypothesis testing, confidence interval, regression analysis, Anova. You might have heard about Anova, which is nothing but analyzing the difference among the mean of the groups, right? So these are certain examples or certain measures of inferential statistics. And for descriptive statistics, I guess Siddharaj covered it all. So, so moving on to the next question, what is a random variable?
Mehul, can you please repeat the question? Your voice
Sorry.
broke in between.
Oh, sorry. So what is a random variable? Did you were you able to hear? What is a
Yeah.
random variable? Yeah.
No, should I go?
Yeah, sure,
It
sure,
is
sure.
it is a possible value, a numerical outcome, which is random in nature, whose future prediction or the path is not fixed. It is not. It cannot be predicted.
Yeah, perfect. So simple, right? Random variable means random. We do not know what the output is. So any variable which has whose output is random in nature, that is what we say as random variable. And this, if you see random variable, the whole stochastic processes are based on this concept, right? So moving on to the next question, what is discrete random variable and what is continuous random variable?
So a discrete kind of random variable says that it is captured at a discrete time interval, and in a continuous random variable, it is observed or captured at a continuous time interval. So there is no lag between the capture observations which we are capturing.
I would not say that as the as the correct definition. Anyone else who want to try? Okay, yeah, go Ashok. Yeah,
So I might not have the correct definition, but I can have an example.
yeah.
So if you coin flip can be considered as discrete random variable, whereas if you want to consider the height of a class, the average height of a class, that could be considered as a continuous random variable.
Yeah, so if you see the definition, Bhupesh, the correct definition is when the outcome can be countable. That's when you say it as discrete, right? And continuous is nothing but when the outcome is not countable. So if I ask you, okay, how many numbers exist between 10 to 12? There are so many numbers. You can say 10.1, 10.11, 10.111, 10.1111, and so on. And this is just 10.1. Then we'll go 10.2 and so on, right? So it is not countable, right? So that is why it is said as continuous random variable. Let's say flip of a coin, or let's say when you roll a dice, what is the outcome, right? So that is what we consider as a discrete. So basically the definition is in discrete, you can count, you can count the outcome, but in random, the outcomes are infinite. Does that sound good? And same goes for height also, right? What Harshad mentioned, right? Height of students, right? It can go like up to like so many decimal places, right? So yeah. So moving on to the next question. Um, what are the properties of a random variable? Okay, so let me change the question. Maybe a better question is what is a probability distribution? You might have all heard about all this PDF, PMF, right? Which is probability discrete function and probability density function and probability mass function. So what is PDF and what is PMF? Are you guys liking the question? I hope the questions are good, right? I mean, we are going from very basic, so don't worry. If you don't know, that is totally fine. We are trying to learn the concepts. Yeah. Yeah, Harshit, please go.
So, PMF is a concept of probability, which is probability mass function is applied to discrete random variables, whereas probability density function, hence it is continuous in nature. Thus, it is applied to the uh, continuous random variables.
Right, but what are these? You are right on that. You are totally correct on that. But what is a PDF or what is a PMF?
It is the of the sum of probabilities till a specific point. Suppose, what should I say? If you have a plot from x-axis is from 0 to 1 and you want to calculate the PMF at point 2, so it is the area under the curve.
Okay, so a simple so as you as as Harshit mentioned correctly, PDF and PMF are the same measures. Okay, they are exactly the same measures. The only difference is PMF is used for discrete random variable, whereas if you see PDF, it is used for continuous random variable. But what is a PDF and what is a PMF? See, it is nothing but it gives you the probability, or it is nothing. Yeah, it gives you the probability that your random variable x takes a certain value. So in simple word, it is just that, nothing else. If let's say you're trying to find what is let's say if you roll a dice and you are trying to find what is the probability of getting one. So how will you mention is probability of x equal to one, right?
Yeah,
So in this case, so what you are trying to calculate is, okay, what is the probability of my random variable to get to achieve this outcome? When you have that specific, okay, I want to get a probability of this what is the likelihood that this random variable will achieve this number? So that is what we say as PMF or PDF, right? Did you guys understand?
yeah. Actually, the area under the curve concept comes in the CDF, which is
Yeah.
like integration of all of it.
Yeah, I did not. So yeah, that was my next question. But just to define the PDF is nothing but it describes the likelihood of a continuous random variable taking on a specific value. That's it. And that's why if you see how we write is P of x equal to x. That's it. That's it. And similarly, okay. And so my next question is, what is a CDF? Yeah. Anyone? What is a CDF? Yogesh? No? Akshat? Gorang? Okay, yeah, go Akshat.
So it is the summation, or since we are talking in terms of density function, it is an integral of all the PDFs to a specific point that you want to compute.
Right, right. So in simple word, how would I have defined as CDF is nothing but it describes the probability that a continuous random variable will take a value less than or equal to a specific value. That's it. That's it. So in PDF you were finding, okay, what is my what like how my my so what is the probability that my continuous variable will take that value. So x equal to x, probability of x equal to x, that is my PDF. What is my CDF? It is nothing but the probability of that my random variable x takes a value less than equal to x. That's it. Either it takes that value or what, or less than that. So the CDF is nothing but it gives you the probability that your continuous random variable will take a value less than or equal to a specific value. Did you all got the concept? Easy. Okay, so moving on to the next question. What do you mean by expected value and variance? Yeah, please go, Siddharth.
Yeah, so expected value is basically a mean of a sequence or maybe sample data and whereas variance measures the spread of a single data point or a single variable from the mean of the entire sequence or the sample data.
Perfect. So that's the correct answer. So basically, your mean expected value is nothing but your average of the average of different values that your random variable is taking, right? And this measure variance is nothing but it measures the spread of the random variable values around the mean. That's it. That's it. So simple definitions, please remember, see, no one will ask all your definition, all this definition, okay, what is mean, what is variance, why we are reading all this, because I just want to make sure the basics are clear. So moving on, what are moments? Anyone? There's a concept of moments. I guess, Bhupesh, I want you to answer this because you have also used moment generating function in one of your projects. So what is moments?
So basically, it captures the shape of a distribution.
Right.
We use four moments, or we use generally. One is a mean, then second is a variance, then there is a skewness and kurtosis. So this using these four moments, we try to define the shape of a distribution.
Perfect. I mean, best answer. I mean, nothing else required. So moments are nothing but your measures, which is basically, which basically tells about the shape of your distribution. So for your first moment is nothing but your mean. Second moment is nothing but your variance. Third moment is nothing but your skewness, and your fourth moment is kurtosis. So this is again a follow-up question to Bhupesh. What is moment generating function?
So moment generating function, it is a function which we use to for a series of random variable. If we have, then it is a function which will be plotted across a series, and using this moment generating functions, we try to calculate a distribution shape. It is basically a function which we try to calculate the shape of any series we have.
Right. So in simple words, how we can put as moment generating function is a function that summarize all the moments of a random variable in basic way. So the next question to all of you is, what is skewness and what is kurtosis? Yeah, please go, Siddhiraj.
Yeah, so skewness tells us about the shape of the distribution, as in if it is right skewed or left skewed. So the data points are more towards the left side of the distribution or more towards the right side. And so we can get a positive skew distribution or a negatively skewed. And kurtosis measures the tailness of the distribution. So excess kurtosis is used to understand if the distribution has a heavier tails or lighter tails compared to the normal distribution.
Perfect. Nothing less, nothing more. Perfect answer. I mean, if I was the interviewer, I'm super happy. So in simple words, skewness is nothing but it's a measure of the asymmetry of your probability distribution of the random variable. Okay. So if you see the normal distribution, it is symmetrical, right? Around the mean, mode, median. If it is symmetrical, right? So basic when we talk about skewness, it means it refers to the asymmetrical of the probability distribution of the random variable. So again, study the concept of, okay, what is positive skew and negative skew. And kurtosis correctly mentioned, it measures the tailness of the probability distribution. So I guess his answer was on point. Next question is, what is covariance and correlation? Yeah, Siddhiraj.
Yes, so covariance and correlation, they both tell us how two independent variables move together. So if we have a positive covariance between two independent variables, then if one independent variable as the one independent variable changes, the other changes in the same direction. Whereas if we have a negative covariance, then they change in opposite direction. And if the covariance is zero, then one independent variable does not influence the other. And when it comes to correlation, covariance and correlation are kind of similar concepts, but correlation tells us more in detail about the magnitude and the direction of the relationship between the two independent variables, whereas covariance does not account for the direction and magnitude does not account for the magnitude. And yeah, correlation is bounded between -1 and 1.
So, like, what's the difference between covariance and correlation?
So covariance can take any value between minus infinity to infinity, but correlation takes only values between -1 to 1. So correlation gives us a better understanding of the magnitude and direction, whereas covariance cannot tell us much about the magnitude or the effect of one independent variable on the other.
Right. So see, the thing which I want to mention is, yeah, it's a good definition. So covariance is nothing but it measures the joint variability of two variables, right? And that's why you see, if you see covariance of x comma y, we are basically understanding what is how two variables jointly measure with each other, right? And correlation, it is nothing but how, I mean, as what he said, we basically you standardize it. So that's why you see the results are between -1 to 1. So, and see, the thing is, all we are doing this just to make sure you understand even the smallest of the concepts. So moving on, what is nominal? So there are different categories of data, right? So do you know what is nominal data and what is ordinal data? Yogesh, Gorang?
I think nominal data is the qualitative data and ordinal data is the quantitative data.
Can you give an example?
Like nominal data is reviews, bad, good, and ordinal data is in numbers 1 to 5.
Um, but if you okay, so basically, how anyone else who wants to answer?
Yeah, both are data types. When we say nominal data, it doesn't captures the ranking of the data. For example, male female, it is a nominal data. But when we say there is some when we rank something from a order of 1 to 5, 1 being the lowest and 5 being the highest, uh, that like how do you see how do you agree that you have a score of statistics? Then I will say strong, 1 being strongest and 5 being the weakest. That's the order which we capture in ordinal data.
Right, perfect. I guess Bhupesh, so Gaurang, your answer was incorrect and Bhupesh answers were correct. So basically, if you see, both are used for both are used in categorical data. When you say nominal, it basically means no order, right? If you see n, just remember n for nominal, n for no order. So when you say nominal, it basically means the order is not important. So as he mentioned, male, female, or boy, girl, or something like that, right? Where the order doesn't matter, that's what is meant by nominal data. Ordinal means where order matters. 1, 2, 3, 4, 5. Let's say people with experience of 3 plus years, 5 plus years, where all this order matters, right? Or let's say people coming out from a undergrad degree, grad degree, right? Stuff like this. So so where orders are important, that's what we say to as ordinal data. So moving on to the next question. Uh, what is a p-value? And this is a very important question, really important question. Yeah, please go, Siddharaj.
So p-value is a probability measure that tells us if the test statistic gives us data that is as extreme as our uh, our sample data, as in uh, mm,
Just say in very simple words.
yeah.
I mean, if,
So yeah,
yeah,
basically it's a probability measure that it is used to check the significance of a test or
simple, perfect, simple. No, see, if you see linear regression, right? There are so many variables, and for every variable, you will get a p-value, right? So it is
mm,
nothing but p-value is used to understand the significance of a variable. So if p-value is less than 0.05, the variable is significant. But if the p-value is greater than 0.05, the variable is insignificant. And where does this number 0.05 came into existence? Researchers or scientists, they basically, it's a thumb rule that okay, we can use 0.05. So also it is not like okay, in the industry people will always use 0.05. I was building a model back then, and we took a significance of 0.10. So instead of 0.05, we took a significance of 0.10. But it again, we need to describe, give a reasoning of why we have taken 0.10. But to your answer, okay, it tells the significance of the variable, very in simple words. So moving on to my next question. Uh, okay, and this is interesting. What is null hypothesis and what is alternate hypothesis? In very simple words. Let's try to understand everything in simple words. Yeah. One hint is we always try to reject null hypothesis every time. Always, you'll see every time you perform a test, the scientists, the researchers, they will always try to reject the null hypothesis. Yeah, please go, Siddharaj. Yeah.
yeah, so null hypothesis null hypothesis states that if a sample mean is different from zero, whereas when it comes to alternate hypothesis, we consider that sample mean is different from zero.
Right, right. So this you told in mathematical terms.
Yeah.
It should be equal to zero, should not be equal to zero, which is correct. But if you want to make someone understand this concept, how would you say that?
Uh,
You defined right now in a mathematical term, which is correct. I'm not denying that. But if I want to explain this to a student, or let's say to a 10th class guy, how would you explain it in easy terms?
mm, so null hypothesis tests if the value that we're chosen is uh, no uh, I don't know how to explain in simpler terms.
Just think.
Mm,
Anyone else wants to try?
So, null hypothesis, we try to prove the basic assumptions about the hypothesis testing, and alternate hypothesis, we try to reject. It contradicts the null hypothesis basically. So,
Still
if
not
we are
still not clear.
not, uh,
Very simple. Tell me in very simple. What is null and hypothesis? Alternate. So basically, I'll tell you guys. So null hypothesis, we assume that there is no relationship between variables, or there is no and there's no relationship between variables, and then or let's say one variable is not affecting other variables. So basically what we're trying to say in null hypothesis is there's no relationship between the variables. An alternate hypothesis, you say there is a relationship between the variables. And why do we reject the null hypothesis every time? Is because we actually trying to create a relationship between two things or multiple things together, right? And that's why we say, okay, there should be a relationship between me studying hard and getting an interview, and passing the interview. So there is a relationship, right? So, and but what in this case, what is my null hypothesis? That okay, even if I study, nothing will happen. And alternate is, okay, if I study, things will happen, right? So basically, in simple terms, null hypothesis is nothing but it assumes there is no relationship. Alternate assumes that there is a relationship between the variables, and that's why you try to reject the null hypothesis and accept the alternate. Very simple. And understood, guys? Okay. So, okay, now moving on to important questions. This was all the basics. Now comes the medium interval questions. Okay, so what is central limit theorem? Okay, I want Yogesh to tell this answer.
Yeah, so I would say that central limit theorem states that in a sampling distribution, like the sampling distribution of a sample approaches a normal distribution if the sample size increases irrespective of the shape of population distribution.
Um, can you repeat it again,
Yeah,
Yogesh?
sure. So in a sampling distribution, a sample approaches normal distribution if the sample size increases irrespective of the population distribution.
You are missing one most important keyword in this whole answer. One most important keyword. Yeah, Bhupesh, please go ahead.
Uh, the random variables are identically it are IIDs, basically independent and identically distributed.
No, that is not the keyword. Akshat, you want to go?
It doesn't change the shape of the population distribution.
No, that is not the keyword I was looking for. Okay, so Siddhiraj, please go ahead. Yeah.
Yeah, so central limit theorem states that the sum or the average of sum or the average of IID random variables approaches a normal distribution as the sample size increases.
Right. See, this is the answer, right? What you guys missed is the sample mean, basically. See, we are not, see, you'll have multiple samples, right? Let's say you have a population, and using that population, you created 10 different samples of data, 10 different samples. So you're not checking the sample. You basically calculate the sample mean and then check. So it is never the sample. Always remember, it is always the sample mean that you are checking. So the answer, how to define it in easy word is central limit theorem. Basically tells that or define tells that as the sample size increases, the distribution of the sample mean, the distribution of the sample mean tends to approximate a normal distribution regardless of the original probability distribution. Understood? So it is not sample, it is sample mean. Okay. Very important. Always remember, very important. If you have multiple samples, you will take mean of those samples, and then if you'll check the distribution of that, and that will become your normal distribution. Cool. Did you understand? Enjoying it? Yeah. Cool. So okay. So why is central limit theorem important? I'm just curious. Anyone wants to tell this answer? Yeah. Please go ahead, Yogesh.
So I would say that because of central limit theorem, the sampling mean would be equal to the population mean, so we can use that information. Also, the standard deviation of the sample distribution would be equal to the standard deviation of population distribution. So by using this information, we can further calculate. Yeah.
Okay. Yeah. Okay. Harshit, please go ahead.
I had the similar answer.
Yeah.
It's
Please go
just
ahead.
that the central limit theorem if is applied on a sample. Using the sample itself, you can approximate the mean and the other statistical numbers for the population.
Perfect, right? I mean, see, when you know how what's the distribution of your sample, and you are saying, okay, I mean, this is a good measure of my population. I mean, that's all right. What else you require? I mean, you don't need to study the whole population. You are saying, okay, I have this sample, and this is a good measure of my population. So that's why that's why this theorem is very handy. very important. So moving on to the next favorite question of interviewers, what is the law of large number?
So I can take this up, Mehul.
Yeah,
I would say the law of large numbers is as and when the number of observations or the samples increase, the sample mean converges to the population mean.
perfect. Yeah, that's correct. So large number is nothing but it states that as your sample increases, the sample mean will get closer and closer to the expected value, or let's say to the population mean of your random variable. That's it. So perfect answer. Just a follow-up question on that. What is a weak law of large number and what is strong law of large number?
So I, I don't know exactly know, but based on the terminology that you use, the convergence must be the difference between between them.
Um, yeah, you are right on that. But yeah, please go ahead, Siddhiraj. Yeah.
Yes, so strong law of large numbers states that the sample mean almost surely converges to the population mean. That means that the probability of the convergence is always one, whereas weak law of large numbers states that uh, uh, the it says that if the sample size of IID random variables increases, number of IID random variables increases, uh, the sample mean will come close to the population mean. Um, but yeah, the only difference is that strong law of large number says that it will always converge, whereas weak law of large number does not specify that.
Um, so your definition to strong law of large number was on point. For weak law of large number, you want to say something, Harshit? Oh, okay. Sorry, I guess it was your previous hand. So your definition of strong law of large number is on point. For weak law of large number, I want everyone to please go and check the definition. Okay. Moving on. Okay, so why this law of large number concept is important and where is it used in the world of quant finance? And this is not an interview question. This is just I want to understand from all of you. Give me one example of where we are using the concept of law of large number.
Um, we use law of large numbers when it comes to Monte Carlo simulations because we in Monte Carlo simulation we try to take a large number of try to perform large number of simulations because when it comes to Monte Carlo the mean of all the simulation converges to the actual mean as the number of simulations increases.
Perfect. This is what I was looking for. See, if you see Monte Carlo, the very first step that we do is we generate almost 10,000 random variables, right? And why do we generate? What's the concept of that? The main concept is okay, more and more we generate, it will come closer to your expected value will come closer to your actual value. So this was on point. And Monte Carlo is if you have not seen my Monte Carlo video, I don't know if you guys have seen, but if you have not seen, please, I'll share the link again in the group. Please go and watch it because in that I've covered two concepts. One, both law of large number and central limit theorem, and how they are used in Monte Carlo. So that is like yeah. So okay, moving on to the next question. Um, what are the properties of a normal distribution? Yogesh, please go ahead.
Yeah, so properties of a normal distribution are it's symmetric towards the mean. Most of the data points are towards the mean. It's a bell-shaped curve, and in the measure of central tendency, we get to know that the mean is equals to the median, which is also equals to the mode. So these are the properties of normal distribution.
So three properties you mentioned, that is your normal distribution is symmetric, and the second is it has a bell-shaped curve, and third is the mean median mode are equal. There are certain more properties. Anyone wants to highlight those? Yes, Siddhiraj, please go ahead.
Yeah, so the normal distribution also has a kurtosis of 3,
Mm-hmm.
and if we perform a linear transformation of a normal distribution, the variable that we get is also normally distributed.
Mm-hmm.
And
There's one rule which is 68, 95, 99.
there's a empirical rule that 68% of the data lies one standard deviation away from the mean, and 95% of the data lies under two standard deviations, and 99.7% lies under three standard deviations from the mean.
Right. So anything on the tails of the normal distribution? Any idea on that?
Uh, the tails of the normal distribution extend infinitely.
Yeah, okay. So they never touch
You
to
never
this.
touch the
Yeah, and they tend to go like this, but they will never touch it, and it will always go to infinity. Any other point, Harshad, you want to mention?
Just the asymptotic nature of the distribution.
So
um
can you define it? What do you mean by that?
Yeah, so it's like it would never touch the zero line and would go on to infinity.
Perfect. Also, just one more thing on the empirical rule, always say that approximately 60% of the data falls within one standard distribution. Approximately 95% of the data falls within two standard deviation, and approximately 99.7% of the data falls within three standard distribution. So the word approximately is important, and it should be it falls within one standard deviation, within two standard deviation. So, okay, moving on to the next question. How would you standardize a normal distribution? Let's say yeah, how would you standardize a normal distribution? Yeah, please go ahead, Siddhiraj.
Yeah, so to standardize a normal distribution, we can subtract the mean from the data point and divide it by the standard deviation. Maybe we can standardize each and every data point. And so a standard normal distribution will have a mean has a mean of zero and variance of one.
Perfect. That's the best answer. I mean, nothing else required. So you need to, how would you standardize any random variable? Let's say if your random variable is normally distributed, let's say you have a point x1, x2, x3 up to xn. So you'll basically calculate the mean and the standard deviation of your data, and just do this x1 minus mean divided by sigma, and do this for all the points x2 minus mean divided by sigma, x3 minus mean divided by sigma. So in the end, what you will get is the distribution that you will get is a Z distribution, or you can also say a standardized normal distribution. And to the point what Siddhiraj mentioned, it will always have a mean of zero and a standard deviation of one. So this was on point. So the next question is, how would you check if your data follows a normal distribution? We have spoken about lot about, okay, what are properties, but let's say if I give you some data, how would you understand like if my data is following a normal distribution or not?
If I would say if the mean, median, and mode are the same number, that's when you can say the data set follows a normal distribution.
But what if, okay, let's say the mean, median, mode is same, but let's say your kurtosis is greater than 3.
We
Yeah.
use a histogram or QQ plot.
Perfect. Yeah, this is what I was looking for. It's very simple. No, why do you want to? Yeah, I mean, just see, how your how your, let's say, just do a histogram of your data, and that will actually give you a shape, right? So, and will use seeing the shape, you can say whether your data is normally distributed or not. Then the second measure is nothing but the QQ plot. QQ plot is nothing but your quantile plot. So what it does is, if you see, it will when you do a QQ plot, it will give you a straight line. So if you have a straight line, then it basically means, okay, your data is normally distributed. But let's say if you have something like this, your line is not straight and it is falling down, or something like that, then you will say, okay, your data is not normally distributed. So this was on point. So any more statistical tests which you guys can think of? Um, yeah, but answer is on point. I'm not denying that. Histogram, QQ plot are good measures to check, but I'm also referring if there are any statistical tests which you can think of.
I think Archibera is one of the tests, but I'm not sure.
Sorry, what did you say?
There's this test called Archibera. I don't know how to pronounce it, but I can spell it out.
Yeah, please spell it.
Jarque
Mm-hmm.
hyphen Bera. Archibera test, as far as I remember.
Okay, so okay,
I may be wrong.
yeah, I don't know about that test to be honest, but what I can think of is a Shapiro-Wilk test, Shapiro-Wilk Shapiro-Wilk test. What is test is that the null hypothesis that the data was drawn from a normal distribution, and your alternate is data is not normally distributed. So you can basically see the answer is right. QQ plot, histogram are good enough, but if you want to do a statistical test, you can check Shapiro-Wilk test. So the next question is, just give me 1 second. Have you heard about, so basically in kurtosis, right? You might have heard about mesokurtic distribution, leptokurtic distribution, and platykurtic distribution. And any idea on that? Have you heard about these terms by any chance?
I think mesocutic measure tells us that the tails are same as the normal distribution, whereas if the I'm confused between these two, but if the excess kurtosis is higher than 3, then sorry, higher than 0, then it's platykurtic, and if it's lower, then it's leptokurtic.
You
But
just yeah,
which did I
you just
think?
say in reverse. So
Because
okay,
I
so
was just
yeah,
quite
meso
confused.
yeah, mesocortic is nothing but your normal distribution will have basically your kurtosis should be equal to 3, right? Leptokurtic is nothing but it is heavy tail, and that's why your kurtosis is greater than 3. So and since your kurtosis is greater than 3, it is heavy tail and it has a sharp peak. But platykurtic, if you see, it has kurtosis less than 3, and it will have a lighter tail and a flat peak. So good on that. Um, Moving on to what is a Z score? Anyone?
So set score is basically as we standardize a normal distribution, the Z score is calculated by subtracting the mean and standard deviation, and Z score is also used to it's also used to understand where the data point lies on the distribution.
Right.
And
Mhm.
uh,
Right. Yeah, Harshit, please go ahead here.
So I just knew about the Z score that it is used for standardizing the normal distribution,
Mm-hmm.
and as Siddharaj mentioned, that it is also can be used to find the placement of your particular point in the distribution as well.
Right. So basically, if you have a positive Z score, it basically means that the data point, right, it is above the mean. And if you have a negative Z score, it basically means that the data point is below the mean. And if your Z score is 0, it basically means that the data point is exactly at the mean. So those are, yeah, good answers. Okay. So moving on, what is a type 1 error versus a type 2 error? Yeah, please go ahead, Siddharaj.
Yeah, so type one error basically is rejecting the null hypothesis when it is true, whereas type two error is failing to reject the null hypothesis when it is false. And
If I ask you to explain in simple terms, how would you say that? Or maybe give an example.
yeah, so when we perform hypothesis testing, so we have to either reject the null hypothesis or fail to reject the null hypothesis. So if after performing the hypothesis testing, we find that the null hypothesis is true, but we don't reject the null hypothesis, then that's a type two error. And if we know that the null hypothesis is true, but we still reject it, then it's a type one error.
Okay, and if I ask you a simple example, if I ask you to explain what is type 1 error versus what is type 2 error to someone who doesn't understand statistics, and just give an example without using null hypothesis, alternate hypothesis, how would you go about that?
Yeah, so basically, it's calling an event false when it's true, but saying that it's true when it's false. So
Yeah.
stating the opposite of what the truth is.
Right. So basically, type 1 error is nothing but a false alarm, right? So when you think something is true, but it is not true, right? And versus what is type 2 error, it is nothing but you are missing it. So
Yeah.
basically, when something is true, but you fail to recognize it. As simple as let's say type 1 error is nothing but you said, okay, the girl is pregnant, but the girl was not pregnant. So when you think something is true, but it is not true, right? You said the girl is pregnant, but she was not pregnant. So it's a false alarm. And what is type 2 error? It is a missed detection. You said, okay, the girl is not pregnant, but actually she was pregnant. So, and that's why we say type 2 errors is deadly, right? Type 2 errors is very deadly because you are saying someone, okay, let's say COVID happened, right? You are saying, okay, you don't have COVID, but actually the guy has COVID or the person has COVID. That's why type 2 error is very extremely dangerous and important at the same time because it is a missed detection. Easy to understand, easy to follow, all of you. Okay, perfect. So, whoa, lot of questions. Okay, so I wanted to ask, just give me 1 second. Let me open my book. Okay, let's focus something on, let's shift gears and let me ask you, if let's say if I give you a data set and ask you, can you clean the data set, right? Or how can you process the data set? What are certain steps that you all will take?
Uh, I can go ahead now. Firstly, I'll try to figure out whether there are any missing values,
Mm-hmm,
and if there is, then there are multiple ways to omit it. Either you can just take away the entire row,
mm-hmm,
or can replace those missing values with the median, which is one way to not remove the dataset and go ahead with it. Then the next process after having removed all the null values would be I would standardize the data so that all of the features they follow the same distribution between 0 and 1, and that is first two steps I can think of. And if there is need for any feature engineering or combining two features into one for better interpretation, that could be the step 3.
okay. So focusing on step one, right? You said if there are any missing values, you can go with median, but do not say that. You should always say, so if let's say if the data is missing, we can check basically different measures like mean, median, mode, whatever suits with the data. And also sometimes, you know, imputing the data with mean, median, no, mode is not the best way. So sometimes you need to use your previous experience or expertise, or maybe talking with different business stakeholders to understand what is the correct way of filling the missing data. So this is the best way of describing how to fill in the best data. So okay, to your point, first point is okay. Let's try to, if there are any missing values, let's try to fill it. Second is, of course, what you said on the standardization, right? So there are different ways of standardizing the data, right? So what you said was I guess min max. There are two type of standardization, and one is the min max standardization, and
One is min-max scalar and the other is standard scalar. So
yeah,
these are the two functions in Python that I
right,
know of.
right. So min max scalar and standardized scalar, right? So why do we do standardization? Because sometimes what happens is the variables that we have are in different scale and magnitude, right? So something like, okay, you might have height of a person, or let's say years of experience of a person, and a salary of a person. But if you see, let's say height, those are in inches and foot. But if you see years of experience, those are just in numbers. If you see salary, those are in dollar terms. So since they all have different scale and magnitude, so that is where you use the concept of standardization. So that is correct. Second is standardization. Any more methods which you can think of? Siddharaj, you have any other outlier detection, right?
Yeah, I
Any?
was going to mention outliers.
Yeah,
So, we can handle outliers. So if the outliers are maybe critical, as in they are important values that should be used to work with the data, then we should consider the outliers. But considering outliers also increases the variance in the data. But in cases where the outliers are not very important, considering the analysis for our data, then we can eliminate the outliers, or maybe we can set up thresholds, as in we can set bounds to which we are selecting the data, as in we can eliminate the lower 5% of the data, or maybe the above 5% of the data. So
right.
that's how we can handle outliers.
Perfect. So outliers are nothing but, outliers, right? I mean, so understanding whether to keep the outliers or whether to remove the outliers is very important. I'll give you a simple example. So in the banking side, if you see during COVID period, US government, they deposit a lot of money in individual bank holders account, right? I'm not sure if you got the benefit, but I got the benefit. So I got some $1,000, $2,000 from my university, right? So now if you see from the banking side, there, if you see the deposits of the bank, there are so many account holders, right? So if you are just putting in $2,000 in everyone's account, your deposit balance will go just like that. It will go increase. But if you see, normally it doesn't happen like that. It doesn't just increase like that. But there was a scheme, the period was different, and that's why outliers, in this case, outliers is important. Keeping outliers is important, right? So you need to understand whether to keep the outlier or to remove the outlier. Any other point you guys want to mention?
Maybe transforming the data, as uh, uh, in case we can include dummy variables if needed.
Right.
So that can be a part of data.
Right. So to your point, Siddharaj, let's say if we want to include a dummy variable, right? That is true. And on the transformation side, of course, sometimes you cannot just include the variable just like that. You need to perform, let's say, a log transformation, right? It's very common even in the modeling industry, right? We do log transformation of our dependent variable and try to understand how other variables are performing. So to your point, you are right. Sometimes we need to perform a transformation on our current variables. So I guess these were the major points. Moving on to the next question. What is a log normal distribution? Uh, we'll wait, Siddharaj. All the answers are given by you. So we'll wait for other one. Anyone else who wants to answer? Siddharaj, but I'll be honest, yeah, your preparation is on point. I'll be very honest with you because see, in the interviews any question can be asked, and the way you are answering, it's on point. So really impressed by your answers there. Anyone who wants to answer this? Okay, yeah, please go ahead, Siddharaj. Yeah.
So, log normal distribution basically takes only positive values, and uh, it is slightly right skewed, and it has a longer right tail because it is positively skewed, and uh,
Yeah,
and yes,
that's all. That's all. Yeah, that's all. Yeah, right. I mean, if you see normal distribution versus log normal distribution can generate both positive values and negative values. The if you see logarithm, the concept of the mathematical property of logarithm is nothing but it will generate zero or positive numbers, right? And that's why the whole concept of log normal distribution came into existence. So basically, the properties are okay. It will generate only positive values. Second is the distribution is right skewed, meaning it has a longer tail on the right side. Okay. And third is yeah, so I guess these two of course it follows a log normal property. So that is one you can add, but I guess it covers in the very first point itself. So yeah, that is on point.
We can always give an example of a stock price as an example of log normal distribution.
Yeah. So always, guys, I'll give you one simple example. If you see, um we always say something like this: stocks are normally distributed, or no, sorry, I just said
Returns are normally
returns
distributed.
are normally distributed, and stock follows log normal distribution. Why do we say stock follows log normal? Because stocks can go zero, but it cannot go negative.
or
Okay,
positive.
yeah, it can be zero or positive, and that's why we always say okay, stock follows log normal distribution where returns follow normal, because returns are both positive and negative. If let's say today my stock value is 100 and yesterday it was not 90, so we saw a positive return. Let's say yesterday it was 100 and today it is 90, so we saw a negative return. So that's why we say stocks follow returns follow normal distribution, because it can take both positive and negative. And this is one statement that you will see in Black-Scholes model, right? I guess Black-Scholes property also one of the assumption is this only, I guess, normal distribution or log normal. So yeah, good on that. um let me okay, so let's say your data is not normally distributed, and you are trying to model your data. Let's say you are trying to fit some quantitative, you're doing the modeling piece. What other distributions will you consider if the data is not normally distributed? So let's say if you see COVID period, right, equities were not following normal distribution because the losses were greater. And if you see normal distribution, right, it assumes okay, it will have a thin tail. But if you see during COVID period, the tails were thick of the distribution of the data. So which distribution can you consider?
uh,
Student T distribution we can consider,
Right? Why?
because it is symmetric as a normal distribution but has a heavier tail.
Right, perfect. It has a thicker tail. So let's say a normal distribution like this, student is like this. So it has a thicker tail. If you see normal was this, student is this. So when you have a thicker tail, you can actually, let's say if you see value at risk, sometimes in value at risk, you use the concept of student T distribution to capture the losses. So these all distribution will stand alone. I'm not sure how to use, but when they come into the modeling world, they are a lot more important. Any other distribution, what you can think? Okay, to a follow-up question to Bhupesh is, what do you think might be some of the limitation of using student T distribution?
To be honest, I'm not sure.
So there's this limitation. It has a limitation of the data. You cannot use a large sample of data to build their model. But modeling in general, we use a large sample of data. So that's why student T distribution has this loss. I mean disadvantage. So any other distribution which you guys can think of? I guess uh, Okay, so I'm don't quote me on this, but there's a distribution. I guess it's a variance gamma distribution. Please go and check if there's a variance gamma distribution. But it is generally used when it also has a very similar properties like thicker tail. So and it also is a better version of student t distribution because it does not have a limitation with the data. But just want you to go and check what is variance gamma distribution and how it is better than student t distribution or than the normal distribution. So moving on to the next question. Oh yeah, most of my questions are complete, so just give me 1 second. So okay, one more point is I have not covered other distribution like the Poisson distribution, beta distribution, because I feel mostly like interviewers are interested in the normal distribution and the log normal distribution. So that's why like I have not covered those concepts. But let me check if I have any other question. Okay, so what is a ANOVA test? Anyone?
So basically, it is analysis of variance where we compare two distributions of variables. So if I have two variables in my data set, I will compare their mean, whether it is equal, all are equal or it's different. So we do a hypothesis testing on that.
So, but why do we use ANOVA test? Like what we are trying to achieve using it?
So we want to check the dependent variables. There is a relation between the dependent and independent variables. So if we say that two variables can be used to predict the dependent variable, then whether its distribution is also matching or not.
Okay,
I,
so
I
basically, yeah, no, that's a good answer. So ANOVA and it stands for analysis of variance. It is a statistical test which is used to compare the means of different groups. And it is why do we use it? Because it helps us to understand whether the difference that you're observing among the group is it due to some effect or is it just random, just because of a random variable or it's random. So that's why if you see the null hypothesis, you assume that the mean of all the groups are equal, and in the alternate hypothesis you assume that okay, at least one group, the mean of one group is different from the mean of the other groups. So basically, but in short, why we are using it to understand, okay, of course the mean of different groups are equal, and if they are not, so if they are not equal, so what is the reason for that? Is there any hidden relationship or is it just because of randomness in the nature? So moving on to the next question. um what is a chi-square test? Okay, a simple hint is see, always if you see when we are trying to do the understanding, okay, which variables to keep in our data set, right? When of course you'll have a bunch of variables. So you of course have to understand whether to keep these variable or that variable. So chi-square is generally used for categorical variable. Most of the times you will see, okay, categorical variables are converted into numbers, right? But before converting them into numbers, what you check is if categorical variable is should we keep it or should we just remove it? So for that, this is the hint. I've told the actual answer, but okay, you guys tell, what is the chi-square test? I have almost told the answer. So anything on that? Yeah.
It might be used for to check the independence of categorical variables.
So not the independence. So basically a chi-square test, it is nothing but a statistical test which is used to determine whether there is a significant relationship or association between categorical variables or not. So basically the test is used to understand the relationship, or let's say if this variable is significant to keep, and these are mostly used for categorical variables. See, for continuous variables you have so many tests, right, which you can use, but for categorical, and this was like one of the interview question also, like so I basically build a PD model which is probability of default model, And if you see the dependent variable is default or no default, right? Yeah, I mean, which is 0 or 1. And there were, of course, there are certain independent variables like male, female, right? I mean, gender of the person, right? And should I keep this or not? So that's where I use the chi-square test. Okay, does that sound good to everyone? Okay, so moving on to the next question. What is a one-tailed test?
Can,
Yeah.
can you repeat the question?
Sorry. So what is a one-tailed test? Or you might have also heard one-tailed test, two-tailed test, right? Okay. Yeah. So Siddhiraj, yeah, please go ahead.
Yeah, so I think when we're testing a significance, as in when we are performing hypothesis testing, uh, one-tailed test is used to check if the variable is maybe if it is positive or if it's considering negative, whereas two-tailed is when we are checking if the when the critic no, I'm sorry, I cannot recollect exactly.
Yeah. Yeah. No worries. Yeah. Anyone else who wants to answer? Just think. Anyone else who wants to answer? Maybe Akshat or anyone. Yogesh, Gaurang. I cannot see you. Are you still with us?
Yes, with
Okay. Okay. Just messing around here.
I'm
Any.
not sure how to define it, but we use one tail test with a reference, whether it's the value lies beyond that or not. So that's why we check whether it's right. With respect to mean, I guess we check where it lies on that side.
Okay, so I want all of you to please go and study one-tail test and two-tail test, okay? And how do we use in the modeling piece? Okay, so moving on to my next question. Just give me 1 second, guys. Okay, let's say now most of my statistics questions are over. There's one question. What is the difference between point estimation and interval estimation? Any idea on that? Have you heard about point estimation and interval estimation? No, no, no. Okay. Any idea on that?
I can take a guess. No, I might
Yeah,
be
yeah.
wrong.
Yeah, please take a guess. Yeah.
Point estimation could be something like use forecasting a future using regression at a specific point. That is what I can think of considering the term, but I'm not sure.
Uh, okay. So basically, point estimation, basically it is nothing but it provides a single value, and that is what is said point estimate, which is nothing but the single value is an estimate of the population parameter. So if you see
Okay.
sample mean, right?
Okay.
It is nothing but the point estimate of the population, right? Sample variance, it is nothing but the variance, it is a point estimate which is used for your population variance. So you guys know this concept, mean variance, you all know this, but it is just the technical terms which are used. So point estimation is nothing but it provides a single estimate, or you can say a point estimate of your population. And what is a interval estimation is nothing but it gives you a range of values. That's why interval. So it basically gives a range of the value within the population. So example can be confidence interval of your mean. When you say confidence, okay, you can say, okay, my mean lies between this range. So that is what we say as confidence. Sorry, that is what we say as interval estimation. Eh, Understood? Okay. So, one most important concept, what is maximum likelihood estimator? most important. I mean, at least from the modeling perspective, so important.
We try to estimate the parameters of the model using maximum likelihood function. Basically, it brings down the error between actual and predicted value by estimating the parameters of the model.
Perfect, perfect. Yeah, that's the right answer. But one a small correction I would say, just to make your answer look better. So a maximum likelihood estimator is nothing but it is a method to estimate the parameters of the probability distribution. Okay, so don't say okay of the model. You should say of the probability distribution. And how would you estimate the parameters? Is by maximizing the likelihood function. And what is the likelihood function? The likelihood function is nothing but it measures how likely it is to observe the given data for different values of the parameter. See, essentially the goal of MLE is nothing but we are trying to understand what are the parameters of our probability distribution function in the modeling world. What are the parameters of our model, and how would you, because there can be multiple parameters of a model, right? Let's take linear regression, right? Now in linear regression you'll have, let's say, three variable. So the three variable can have different coefficients, right? Different parameters, right? How will you understand which one to take? So you basically take that parameter where the difference between your actual value and your predicted value is the smallest, or it is close to zero. So that's why you need to train your models. When you train your models, you basically tell, okay, these are the actual value. So what happens is the model or the linear regression model will basically try a bunch of different values using the MLE method. And then it will say, okay, these are the value wherein the difference between your actual value and your predicted value is the closest. So now if you see there's a concept of ordinary least square, OLS. In linear regression, people say OLS. Now, how OLS is different from this linear regression is, in ordinary least square, you basically minimize the difference between the square. You minimize the squared
Right.
difference between the actual value and the predicted value. Basically, the square difference between. So something like, let me share the whiteboard. So let's say, yeah, let's say you have this way. So let's say this is your actual value and this is your predicted value, right? Let's say um something like, let's say, okay, x1 is my actual value, and let's say y1 is my predicted value. Okay, something like this. So in OLS, what you are trying to do is you are trying to basically you are trying to minimize this thing. That's it. So you are trying to minimize the sum, I mean the square of the difference between your actual value and your predicted value. That's it. Understood this concept? And that's why we say ordinary least square. Why do we least is nothing but minimizing the square, the difference between. Okay. So just give me 1 second. Let me remove this. And my next question to all of you is, what are the steps in MLA? I understand we are trying to minimize the function, but what are some steps in MLE? This I want all of you to read. Okay. Um. So yeah, this was all, guys. Uh, one last question. A few, two or three last question is, what is the difference between correlation and causation? You might have heard the term causation, right? Mm. Yeah. Sorry, Siddharth. Go ahead. Yeah, I did not see your hand raised.
I can try. Uh, Correlation basically tells us the relationship between the two variables, and whereas when it comes to causation, if one variable impacts the behavior of the other variable, but it's not the similar case it's not the similar case vice versa. As in, one example could be, uh, if uh, if we are considering usage of maybe uh, organic food, then maybe rich people might consume a lot of organic food. But when it comes to, we cannot say that if you consume more organic food, then you are likely to be rich.
Yeah,
So that
perfect.
could be maybe one example.
Yeah, that's a very good example. So basically, correlation is nothing but it indicates the relationship between two variables, right? But it does not tell you whether or it does not imply that one variable causes the other, right? It just tells you what is the correlation between them. But causation actually indicates that whether one variable directly affect or it causes the change in another variable. And that's why causation is very important. We all look for correlation, whether how correlated they are, but causation actually tells you whether one thing is implying or is it causing the second thing. So that's why knowing this concept is very important. And how would you measure correlation? Can you guys tell me?
It ranges from -1 to 1, 0, where
How would you calculate correlation? The term is Pearson correlation. So
Pearson.
Pearson correlation, and the drawback of what is the drawback of Pearson correlation is it measures the linear correlation, not the non-linear. So this is very important. So that's why that is one of the drawback, that even if there will be a non-linear correlation, it will not measure that. So this is one of the, and that's why causation is important to understand whether one thing is causing the other or not. So few more questions which I wanted to ask is, let's say if your model is underfitting or overfitting, right? So let's say if it's underfitting, what would you do? Let's say you build a linear regression, and this is not statistics, but more on the modeling piece. Let's say you have a linear regression model and it is underfitting. What would you do? Think.
We can try to increase the data size, samples, size of a sample. We can add new features to the model,
Right. So that
and
that's on point. Increasing the sample size is important. Second is increasing the variables in your data. Sometimes you might have limited your variables. Let's say you have taken just 3 variables, but instead you should take 5 or 10 variables. So that's when your model will be able to predict. So any other point of for underfitting, increasing the sample data, increasing the variables in the data. Any other thing?
I'm not trying to. I'm trying to recollect, but
No, but those 2 points were it was really nice. Okay, let's deal with overfitting. Let's say you have a regression model. There was overfitting. How would you reduce your overfitting?
We can use, I guess, lasso reduces the number of features to absolute zero, if I'm not wrong. There's either lasso or ridge that reduces the number of features to absolute zero. That could be one approach.
Okay, and what's next?
we can penalize the number of variables we used in the
So
model.
what Harshit mentioned, the lasso regression, the ridge regression, which is also called L1 and L2 regularization techniques. Those are actually those, if you see the cost function, those penalizes these only the cost function. If let's say
Okay.
if one variable is not not capturing the variance in the data set, it penalizes that variance and make it either to zero. That is what we say as lasso regression. And it or in ridge regression, the
Patient drops to absolute, close to zero.
close to zero. It is not absolute zero, but it is very close to zero. So perfect. So these are two techniques which are used to reduce overfitting. What else? What else? So to Bhupesh point, basically, reducing the sample data, reducing the data, and reducing the variables can one of the technique. Why include more variables, right? If those variables are not not capturing the variance, and that's what lesson rate actually does. It removes all those variables which are not capturing. So those are certain good techniques. Just revisit these concepts, because this can be asked, not I mean, if you're interviewing for a modeling role. So any more questions which you guys can think of which I have not covered in this mock?
So I don't have any question at top of my head that is not covered. But yesterday I interviewed with a firm, and the first, well, like we can have a separate conversation about it.
Yeah. Okay.
Yesterday's interview was
Yeah.
brutal.
Yeah. Let me stop the recording. But any other questions from your end? Okay. So let me stop the recording. Thank you everyone for joining in.